Let's continue. So we move from leading tracker to supplier to a leading solar cell module company. Actually, Trina is doing much more, but this is here the focus on modules. And we have with us Rocky Lee, who is the product manager, and he will talk about ultra-high power dual glass bifacial modules to boost the energy yield. Rocky, the floor is yours.
Thank you for having me, Michael. I'm very glad to be here. I'm gonna share my screen. Please kindly check that you can see my screen and hear my voice clearly.
Very good. All perfect.
Okay, great. Thank you. Okay, hello everyone. This is Rocky Lee from Trina Solar product management team. So my today's topic is ultra high power dual glass bifacial modules, boost energy yield. So my presentation will mainly come from three major parts. So the first part is the Trina Solar overview. I will outline Trina Solar profile and bring the latest updates. And the second part is the bifacial module with dual glass structures. So I will just present the reliability of dual glass structures and Trina Solar, specifically the Vertex flagship 670 watts plus Vertex dual glass bifacial modules. And in the third part is the Trina bifacial module, boosted energy yield, lower LCOE. I'll share the empirical study of the energy yield gain, LCOE impact assessment of the 210 Vertex series modules. Okay, so let's look at the first part. So Trina Solar, we are founded in the 1997 and headquartered in Changzhou, China. And we are the world leading PV and smart energy total solution providers. So we've been listing on Shanghai Stock Exchange since June 2020. And our globalization footprint reaches every major continent all around the world and more than 100 countries and more than 17,000 employees worldwide. And notably, by this year's April, we reached meaningful milestones of 100 gigawatts cumulative shipment. And 2022 is also Trina's 25 years anniversaries. And in these special years, we reached these remarkable milestones. So 100 gigawatts of PV modules is a meaningful number. This can generate about 135 billion kilowatt hours of the clean energy powers and reducing annual global CO2 emissions by 135 million tons. So this is equivalent to planting 7.29 billion trees. And during this year's Intersolar Europe, so the solar industry just break the threshold of the deployment exceed 1 terawatts globally, and China contribute around 10% of the total of this total number. So we continually contribute to the global green energy transition and contribute to the carbon neutrality. And in terms of the Trina module products, Trina provide a product portfolio with 430 watts to 670 watts power output range, covering all the application scenarios. And Trina recently upgraded two of our production lines, from this small format module and medium format modules. And the upgraded product portfolios have 20 to 100 power advantages above than the industrial average. And for these production lines, specifically for the large format modules, the dual glass bifacial type is available. So the dual glass type would also be the best fit for large scale solar plants. So let's look into the second part, the bifacial modules with dual glass structures. So for a bifacial module, it can generate electricity from its front and rear side. And in terms of the architectural level, the bifacial concept requires the standard replacing the standard solid backsheet with either glass or a transparent backsheet. Double glass encapsulations provides additional protection to embed the solar cells because of its excellent reliability and durability. So Trina also chose the dual glass structures as our bifacial panels encapsulations configurations, given its better performance to deal with all the aging factors in the nature. So when we talk about the Trina's dual glass bifacial modules, Trina actually started the dual glass bifacial module shipment from 2015. So we're one of the earliest to wide spreadly deploy the bifacial modules. So till now, our cumulative bifacial module product deployment exceed 20 gigawatts globally. And thanks to the dual glass structures, the excellent reliabilities, our Trina's bifacial modules can provide 30 years of power warranty and with 0.45% annual degradations of our PPERC series. And in terms of the reliability, the dual glass structures can provide the excellent anti-micro crack, higher fire ratings, and better dynamic load performance. And these modules can be resistant to the salt mist, ammonia, dust, and sand environment, as well as the PID free performance. And for the bifaciality, for the PPERC series, the bifacial modules bifaciality is around 70%. So on these dual glass bifacial structures, I'd like to introduce the Trina's flagship panel, 600 watts, 670 watts modules. So these panels just inherit all the advantages of the dual glass modules, while we have several more unique features. So this panel is based on the 2 10mm wafer cells platform. So we just embed several cutting edge technologies like the multi-bus bar, half cut, NDC is short for the non-destructive cutting, dual glass bifacial, and enhanced frame design. And notably, this NDC cutting technologies let the cell cutting surface, as you can see from these pictures here, it becomes much smoother than the conventional cutting tech. Together with the framed optimized frame profile design, so thicker frame profile, bigger cavity. So as well as the dual glass symmetrical sandwich-like structures, so give the panels reliable performance in terms of the mechanical properties and environmental aging tests. So on top of that, Trina 670 watts modules, we conducted the one standard is based upon the UL 2V certifications and multiple partial tests to verify the panel's reliability. We conducted the non-uniform snow load test, static loading under the extreme low temperature, 35 millimeter bigger hail impact, enhanced dynamic load test and wind tunnel test. And Trina's modules passed all the tests and to demonstrate these modules superior reliability. And what's more, our 600 watts, 70 watts dual glass bifacial modules also passed rigorous tests in the PVL and RETC to reputable and influential test labs in extended test field. And this panel is awarded as the 2022 top performers in PVL and in RETC. So in particular, the ultra high power Vertex 670 watts modules pass all reliable test items in PVL PQP program, so which include the dam heat, thermal cycling, PID, LDTID, mechanical strength sequence, all these tests. So this means that the modules have excellent reliability and performance to deal with the extended reliability test So which means it can be safely deployed in the harsher climate regions like the high temperature, high humidity, and large temperature fluctuations. So in PBL, notably in PBL, so this is the 18th recognitions in a row for Trina. So making Trina Solar the solar company with the most wins. And in RTC, top performers, Trina also is the third consecutive years to win the RTC award. So it just highlights Trina Solar's commitment to excellent quality consistency and high reliability and outstanding safety of our module. Okay, after the reliability, I like to jump into the bifacial module, boost the energy yield, lower LCOE, the third part of today's presentation. Okay, before we dive into the empirical data, I'd like to have a quick overview of the bifacial energy principles. So the blue formula here tells for bifacial modules, the overall energy yield equals the front side energy yield plus the backside energy yield. While the backside energy yield could be expressed at the front side energy yield times the bifacial gain, while bifacial gain is the concept to indicate the energy generated by the rear side of the module as the fraction of the energy produced from the front side of the module. So it equals the bifaciality times the rear side the ratio, the relation that reaches the rear side is G rear divided by the ratio that reaches the front side, which is the G front. So the bifaciality, so this figure is the module's property, while for the G rear is impacted by various conditions like the diffusion light, and reflection light, and it was further impacted by environmental conditions like the albedo, the project design, like the height, which illustrated by these pictures in the bottom. Sorry, my PowerPoint just gets stuck.
Your screen switched. I think we see your.
Yeah, sorry for that. I need to. Okay, can you see it now?
All good, just go in presentation mode again.
Okay, I do apologize for the inconvenience. Okay, I'm gonna start from these slides. Okay. Can you see now? Okay, great. Okay, so then on the bifacial principles and the basis, and to further study all these factors impact, Trina just conducted a lot of the tests and built up this empirical test sites to monitor and analysis. So this empirical project is in Changzhou, our headquarters. So in our state-key laboratories. So this project's mainly study the albedo impact to the bifacial gain. So all the panels in this project are horizontally placed under the different ground surface. So in the grass surface, so the albedo is around 18%. In such conditions, the bifacial gain is around 5.8%, 5.9%. While in the sand, in the sand environment with 35% albedos the bifacial gain is around 11.5%. In the cement, so though the albedo is relatively low, is 30%, but the elevations is higher than the sand. So we also get the average 11.5% bifacial gain in this scenario. While in the large part is the white substrate, so this can provide 70% albedo reflection ratio, and in such conditions, so the bifacial gain can reach 22.5%. So also we conducted the analysis in terms of the latitude and scattered light, as well as the mounting height of the impact of the bifacial gain. See, for the the comparatively data show that the higher latitude contribute to greater energy yield gain. While for the scattered light, we use the Tianjin project and the Gormut, these two projects. You can see here the latitude is basically the same, and while for the scattered light, the Tianjin has more scattered light than the Gormut, and in such conditions, the Tianjin project has more bifacial gain, which can draw the conclusion that more scattered light will contribute to higher energy yield gain. And in terms of the mounting height impact, so with higher elevations, so which is also known as the mounting height, the solar radiation will become evener on the both faces, and therefore can result in higher energy yield gain. So after all these studies, for Trina's new Vertex modules, we collaborated with the reputable third parties to Rheinland and CPVG to build up a multiple empirical test sites worldwide to test the 210 modules energy yield performance in different environment locations. So for the bifacial study, I'd like to share the data in Hainan, China, Germany, and Incheon, China. So the first one is the study in Hainan, China. This project is located in Hainan, China. So we work with Rheinland in the fixed-tailed systems, so grass ground. So these 3 months duration data show that there's a average 6.1% energy yield gain than the monofacial module. While for the project in Germany, still we work with TUV as well in the fixed-tailed installations. The project in Germany, it has its ground has higher albedo, and on the other hand, Germany has higher latitude. So these two factors contribute more energy gain comparing to the last project. So the results show that there is 8.6% bifacial gain comparing to the monofacial module. And the next project is the project in Incheon, China. So Incheon is one of the most abundant light resource places in China. And we conduct this analysis and it's still in the fixed-tailed installations. The ground surface is sand. So, but as you can see from the picture here, the pitch, which means the distance between the different rows is quite big. So, which gives the bifacial surface a better exposure to the environment to get the whether the reflection light or the diffusion light. So in such optimal conditions, so we get 10.51% energy yield gain than the monofacial modules. So these three empirical projects test data is almost in line with the Trina's sticky laboratories research. So this demonstrates the energy yield boost in different environment, in different system design. And then what about this bifacial gain contribution in terms of the LCOE? So Trina is entrusted the third-party audit to conduct the analysis. So this virtual project is in Spain, and this location and the corresponding GHI, diffusion, horizontal, all this project info is listed here. And in terms of the project design, we have two simulation groups. One is the fixed tilt, 2V, which means two portrait fixed tilt installation design with a GCR 43.5% with 11 meters pitch, while for the tracker system is one portrait. The GCR is 41.5%, while the pitch is 5.75 meters. So we create these four cases, these four groups, and we run the PR, and we calculate the CapEx, and the ultimate LCOE comparison is listed in this table. So for this 500 megawatts PV virtual plant in Spain, so if we compare the case 3 with case 1, so in the fixed tilt systems, the bifacial modules, the DG, this figure means the bifacial modules. The bifacial modules can lower the LCOE by 1.93%. So in the tracking system, so if we compare the case 4 and the case 2, so, and the number is here, the case 4 here, and comparing to these two. And in the tracker system, the bifacial modules can lower the LCOE by 2.26%. And in this virtual project, in these 4 cases comparisons, we can draw a conclusion that investing in a PV configuration with the tracker plus the bifacial modules will get the lowest LCOE. And based upon the bifacial plus tracker configuration, I'd like also to introduce the 670 watts plus bifacial module system value, system advantage in terms of the CapEx and LCOE. Still the project in Spain, but we entrusted the Fraunhofer to conduct the analysis of Trina Solar Vertex 670 watts module plus tracker, comparing to the reference 1 and 2 bifacial modules plus trackers. The Vertex modules can reduce the CapEx by 0.95 euro cents thanks to its ultra high power output, so which can significantly reduce the initial investment from the logistic part, electrical system, mounting or installation part, and thus even lower LCOE, 1.9% lower LCOE can be achieved. So choose the ultra high power module, choose the ultra high power bifacial module plus tracking system, which can lower your LCOE and maximize the investment return. And lastly, I'd like to say that our capacity is Trina's by the end of this year, we will have 65 gigawatts module capacity, while 50 gigawatts cell capacity. So quick summary of today's presentation. So for the the first part is the dual glass structures provide the bifacial module excellent reliabilities. So Trina is our newest flagship product, 600 watts plus ultra high power bifacial modules. Reliability is assessed by various extended reliability tests and awarded by the PVAL and RETC top performer. And the second part is bifacial modules can boost the energy yield in different environments, and our empirical data show that our 2 Vertex modules can have 6.1% to 10.51% in the different empirical project locations. And the third part is our bifacial modules. The bifacial additional power gain from the backside can lower the LCOE. So we, in the Spain virtual project assessment, The bifacial module can lower LCOE by 1.93% in the fixed tail system, while 2.26% in the tracking system. Okay, so that's all for my presentation. Yeah.
Wonderful, Rocky. Thanks a lot. That was a lot of data. I think a lot of questions are waiting for you in the chat to be answered. Yeah. So since we're a bit behind, I would leave it with this. Thanks once again also for showing what a wonderful couple bifacial and trackers are in your presentation.